Hi everybody, welcome to AGAA-MATH. This is Rakesh. Today we are going to learn about find whether the given rational is terminating or non-terminating without actual division. In the previous videos we have learned how to find whether it is a terminating or non-terminating by performing the division. Here we are going to learn how to find without actual division whether the given rational is a terminating or not. So before going to know about those all, so let us see some basic questions here, basic understanding. For example, let me coming to the decimal fractions we call. So what are the decimal fractions means if the denominator, so whatever the numerator we have, for example 23 by 100 or 14 by 10 or 2564 by 10. So whenever the denominator are like 100, 10 or like 74 by 1000. So whenever the denominators are like 100, 10 or 1000 something like this, it means these are powers of 10, right? So 100 is nothing but 10 square. So 10,000 is nothing but 10 cube, right? So the denominators are the powers of 10. So such rationals or such fractions are said to be the decimal fractions or such decimal rationals. So in this, so when it consists with the powers of 10, it is very easy. For example, 23 by 100 means I can write very easily directly without performing division. Even I can write it as 0.23, and this I can write it as 1.4, and this I can write it as 256.4, and this I can write as 0.074. So without performing the division itself, we can write into the decimal, right? So find whether the given rational is a terminating or non-terminating means, so 0.23 is nothing but no decimal numbers continue, so that this is a terminating and this is also terminating, so this is also terminating, this is also terminating. Means see that when the denominators are in this powers of 10, so it is very easier to convert into decimal, as well as we can know whether it is a terminating or non-terminating. So denominator should be in this form. So 100, if I see the 100 and write into the exponential form, it is 2 square into 5 square, or even you can write it as 2 into 5 whole square. Coming to the 10, it is nothing but 2 into 5. Coming to the 1000, it is nothing but 2 into 5 whole cube. So if it is a 10,000, it is nothing but 2 into 5 whole to the power 4. So 4 zeros, 1 is followed by 4 zeros, so power 4. 3 zeros, power is 3. 1 zero, power is 1. 2 zeros, power is 2. If you do prime factoration, you get that. If you do the prime factoration for 10, what do we get? Prime factoration for 10, like 2 5s and 5 1s. So prime factoration of 10 is what? 2 into 5. Right? So see that the denominators, if they are in the form of like 2 power into 5 power, 2 into 5 whole power, so it is easier to know whether it is a terminating. And let us see a few more examples here. If I take any other number like 3 by 2, so when I perform a division, so 2 ones to 1.02510. So it ends here and no decimal is repeating and nothing, no continuation in the decimal part. So this is a terminating, right? So here I performed a division and I knew it. So remember one thing, whenever the denominator is 2, or even you can take 3 by 4, you get 0.75. Means 4 is nothing but 3 by 2 square, right? 3 by 2 square. 3 by 2 square. Even if it is 3 by 5, it is very easy. We can write it as 0.6. If something is 24 by 25, so it is very easy to convert into decimal. 24 by 25 means is a 0.96. Means 25 is nothing but 5 square. If I see the denominator part, the denominator is 5 square. So by observing all this, you have to understand, if the denominators, we are speaking about the denominators here. If the denominators are like, if the denominators as 2 power 2, 5, like 2 power n or 5 power n or 2 power n into 5 power n, where nm are whole numbers, n belongs to whole numbers. So if the denominators in this form, if the denominators are in this form, we can say whether, if the denominators are in this form, we can say that given rationals are terminating. If not, they are non-terminating. Let us see some examples here now. Before you watch the video, subscribe it, click on the bell icon for more notifications. Let me take a number. Let me take a rational number here, that is 35 by 50. So whenever they give any rational number, instead of doing the division, what you have to do is take only the denominator and do the prime factoration for that. So if you do the prime factoration, 2 25 times, and this is 5 times, and 5 1 time. So it is nothing that, if I write the denominator, that is 2 into 5 square, 2 into 5 square, as we have seen in the before. That is, if the denominator is in the form of what, 2 power n into 5 power m, where nm belongs to whole numbers, so that it means what, this is terminating. If the denominator is not in this form, like 2 power n into 5 power m, then where nm belongs to whole numbers, or we can say that non-negative integers, right? So if nm like whole numbers, so this is what, now this is denominator in the form of 2 into 5 square, right? So if this is a terminating, I can say very clearly that 35 by 50 is terminating. Right? Now let me take one more example, like 7 by 8. If I take 7 by 8, it is 7 by 2 cube. If you do the prime factoration for 8, you get 2 4s, and this is 2 2s and 2 1s. So it is 2 cube, right? So here, this 7 by 2 cube into 5 power 0 I can write. Means 5 power 0 is nothing but 1. So 5 to the power 0 is nothing but 1. So 2 cube into 1 is 2 cube. Means the denominator, I just now I told you, nm what belongs to non-negative integers or whole numbers. So nm belongs to whole. It means 7 by 8 is also terminating. So that 7 by 8 is what? Terminating. Is terminating. You have to just check with the denominator. If the denominator is in the form of 2 power n into 5 power m, so it is a terminating. If not, it is non-terminating. Let us see one more here. 11 by 12. 11 by 12. 11 by 12. When I like 11 by 12, if you do the prime factoration for 12, you get like 2 square into 3. 2 square into 3. So here the denominator is not in the form of 2 power n into 5 power m. 2 power you have, but 5 you don't have, even you have another number. Instead of these, no other should lie in the denominator, but you have 3 here. So that this is, it means 11 by 12 is non-terminating. Is non-terminating. So this is how do we check whether the given is terminating or non-terminating without actual division? Simple, the denominator should be in the form of 2 power n into 5 power m, or with power of 2, or only with the power of 5. Other than this, if you have any other digit in the exponential form when you do the prime factorization, it is non-terminating. I hope you all enjoyed and you knew what is how to find whether it is a terminating or non-terminating without actual division. If you have any more queries, give us mail at askagaamath@gmail.com. Thank you.